Welcome back to 13.2, part 2. There's 3 parts to this set of notes because I want to divide it into 3 because each concept, even though it's related, it's a little bit different. But for this lesson, we're going to concentrate on the spontaneity rule. So the spontaneity rule says, and I'm going to be repeating myself over and over again so you get it because it's just getting it. Once you get it, it's actually kind of easy. Using a redox table, one can determine if a reaction will be spontaneous or non-spontaneous. There's 2 concepts here. A reaction is spontaneous, so we're going to use this word to show that that reaction is actually occurring. You don't have to heat it up, you don't have to ask it nicely, it just automatically reacts. It's if the oxidizing agent is above the reducing agent on the redox table found in your data booklet. A reaction is non-spontaneous if the oxidizing agent is below the reducing agent in the redox table. So here's an example of what this looks like. Spontaneous reaction, the oxidizing agent is higher than the reducing agent. As we knew from before, here are all of your oxidizing agents are on this side. This one being your highest oxidizing agent. These are all reducing agents on this side, this being your highest reducing agent or your strongest reducing agent. If your oxidizing agent is above your reducing agent, then it's a spontaneous reaction. It's going to happen. A non-spontaneous reaction looks like this. You have your oxidizing agent higher up than your, your reducing agent is higher on the table than your oxidizing agent. That is a non-spontaneous reaction. This is what it looks like again. To repeat myself, if your oxidizing agent is higher than your reducing agent, it's spontaneous. And all you have to do, kiddos, these will be given to you in either in a reaction or in a list of substances. You have to actually plot them on the redox table, and then you have to just physically take a look. If your oxidizing agent is higher than your reducing agent, it's spontaneous. If your reducing agent is higher than your oxidizing agent, it's non-spontaneous. We also can look at this backwards and build a redox table from that data to see if something is oxidizing or reducing, if something is spontaneous or non-spontaneous. Then you take a look at your oxidizing agent, your reducing agent, and you plot them, and then you can make a redox table. So let's walk through a few examples. Okay, so 3 reactions among indium, cobalt, palladium, and copper were investigated. So here's reaction number 1, here's reaction number 2, and reaction number 3. The reaction equations below indicate that 2 spontaneous reactions occurred. Here's spontaneous reaction number 1, spontaneous reaction number 2, and there's only one combination that did not react. There's no evidence of reaction, which means it's non-spontaneous, okay? So what we need to do is we need to construct a table, a little mini redox table of half reaction equations showing the relative strengths of the oxidizing and reducing agents. So because we're doing a half reaction equation, we're looking at the reduction half reaction. So let's go through this step by step. Let's take a look at the 3. Here's our 3 reactions. The first one, spontaneous, spontaneous, and non-spontaneous. Okay, so let's take a look at the first one. Here's the first one. So cobalt is your oxidizing agent, and it is a spontaneous reaction, which means that when I'm making my table, this goes above this. So I'm just starting it out. Here's my cobalt, and here's my indium. It's higher. My cobalt is higher than my indium because this is my oxidizing agent, this is my reducing agent, and it just needs to go higher. No big deal. Let's take a look at the next one. Here, copper plus cobalt is a spontaneous reaction, okay? So what does that mean? It means that the oxidizing agent is higher than the reducing agent. Copper 2 ion the copper 2 plus happens to be the oxidizing agent, so it has to go higher than the cobalt, because we're comparing copper and cobalt. So copper now goes above the cobalt, okay? And the cobalt is already above the indium because we figured that out from the first one. Let's take a look at the third reaction. Copper 2 plus ions are reacting with palladium, And you can see that copper 2 is the oxidizing agent. It's non-spontaneous, which means that copper is going to be actually below the PD solid. So that goes above here because it's non-spontaneous. The Ra is actually above the OA. Okay, cool. So that then once that's done, once you figure out the sequence of these entities, you just have to fill in the missing information. So you have to fill in everything that's missing. So, and then you have to kind of follow, not kind of, you absolutely have to follow this. So you have your oxidizing agent plus the number of electrons is going to give you your reducing agent. So we figured out these guys we already plotted from before. All we have to do is fill in the missing info, and we come up with a mini redox table. This is your strongest oxidizing agent, your weakest oxidizing agent, your strongest reducing agent, and then your weakest is here. Okay. I should actually, just to make life easier, I'll change the direction of the arrow. Strongest reducing agent, and my weakest reducing agent is up here. Oh. Okay, let's do another example. A student performed the following reactions. Construct a table of redox, a little mini redox table with the relative strengths of oxidizing and reducing agents. Okay, cool. So here are our three. Notice that they're all spontaneous, 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 spontaneous. So in each of these three, the oxidizing agent is above the reducing agent. So all we have to do is actually figure out what our oxidizing agents are. Oxidizing agent, oxidizing agent, oxidizing agent. They all have to be above this guy. PT2 plus is above PD, and CO2 plus is above the magnesium solid. So let's walk through it little by little. So cobalt solid plus palladium 2 plus ion is spontaneous reaction. So my palladium 2 plus, my PD 2 plus is going to be above the, it's going to be higher than the cobalt. Right on. Let's move on to the second one. So now we're comparing PT2 plus and PD solid. It's spontaneous, which means that this is above the PD. So I have to just make sure it's above the PD. Okay. Awesome. Last one, let's take a look at the reaction between magnesium and cobalt. So here we have a spontaneous reaction again. The cobalt is going to be above the magnesium, which means, and the cobalt's here already, kiddos, which means that the magnesium is on the bottom. So there it is. Once you have this set up, kind of like a little ladder thing, we go ahead and fill in the missing information using the template. Oxidizing agent plus number of electrons is going to give you the reducing agent. So you fill in your electrons, PT solid. This guy here is also, see, it has to actually gain 2 electrons to become PD solid, okay, and so on and so on. And then, of course, you have your strongest oxidizing agent at the top, strongest reducing agent on the bottom. Okay, we've done a lot so far. We've looked at oxidizing agents, reducing agents. We've looked at building a mini redox table using a data in a table. And we also built a mini redox table using the rule of spontaneity. Next class, we're actually going to be predicting redox reaction from a solution. So that's kind of fun too. All right, can you please, please, please work on questions 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. They're found at the end of your note package. I will post the key later on today or tomorrow. Have a great day, kiddos. Bye-bye. Oh, and we're going to meet later for Teams. So I'll talk to you later.